Right, the intention of this lesson is to build on what we were doing in last lesson. The learning objectives is to find a general formula for the differentiation of an e function and the differentiation of a log function. We're then going to learn to express these general formulas in words instead of in mathematical language. And then by using the wordy definition, we're going to apply it to solve problems in a more easy fashion, quicker fashion. The first thing we've got to do is we've got to look at what the formula says on the page 25 of the Formula and Tables book, and it says if we've got y is equal to e to the x, when we differentiate an e function, it does not change. Now, what we're going to do is we're going to apply it to y is equal to e to the function of x. Now that means the x here is being replaced by f of x. So then we use the inverted commas technique. And what we now have is the formula x is actually equal to a function of x. And then we differentiate this formula x with respect to x. Now, when we differentiate a function of x, notationally, we write the differential of a function of x as f dashed of x. And from last lesson's work, we now refer to this as the multiplying factor. And this is using the chain rule in a disguised way. So now we're up here, and we are going to apply what we've just done on the right-hand side. So when we differentiate the left-hand side, the differential of y is the dy dx. The differential of an e function, well, what does the formula say to us? It says when we differentiate an e function, it does not change. So it's going to be e to the f of x. And then what do is we multiply by the multiplying factor, which is the differential of the power. So we're now going to write that in words. So here we go. When we differentiate an e function, when we differentiate an e function, it does not change. Then we multiply by differential of the power. So let's see this in the context of a few questions to make life easier. Number one, y is equal to e to the 3x squared. So we differentiate this and it becomes dy dx. And when we differentiate an e function, according to the formula book, it does not change. So it becomes e, so it doesn't change, so it remains e to the 3x squared. But what we had then got to do is remember to multiply by the differential of the power. The differential of the power is multiply by the power to get 6x, and then put the power down one. And then usually we rewrite it with the 6x at the front multiplying the e to the 3x squared. Number two, y is equal to e to the sine x. Just to our A to memory, sine, cos, minus sine minus cos. When we differentiate, we get dy dx. When we differentiate an e function, it does not change. It remains as it was. So if it was e to the sine x, it's still e to the sine x. And then we multiply by the differential of the power. The power is sine, and we differentiate it, it becomes cos. So it's e to the sine x on cos x. That's the end of that one. And then number 3, you get y is equal to, say, e to the minus 7x. When you differentiate this, the e function does not change, so it's becoming e to the minus 7x. It stays the same. And then we multiply by the differential of the power. And so what's the differential of minus 7x? Well, it's minus 7. Cut a few corners. We tend to just go straight to write it at the front rather than writing it at the end and then rewriting it. And that's the end of that part of derivation. And now we're going to look at something similar for y is equal to log f of x. The first thing we're going to do is we're going to look at the formula book. And in the formula book, we've got y, let's do that in blue, y is equal to ln modulus of x. So y is equal to ln the modulus of x. And when we differentiate it according to the formula book, it's written quite simply as 1 over x. Simple as. So when we compare it to what we have, because what we have is we've got y is equal to ln modulus f of x, which means the x here is now equal to the f of x in there. So the x in the formula is equal to the f of x in the question. We're now going to differentiate this, and we differentiate this with respect to x. As we saw on the previous page, f becomes f dashed. And it's referred to, because it's the chain rule, the multiplying factor. So what does that mean when it looks over here? So when we differentiate the right-hand side, we get dy dx. I don't know why that's behaving badly. Try that again. We differentiate this side, it becomes dy dx. And what's the formula say to us? This is the formula here. It said it's 1 over the x. Now we already know that the x inverted commas is f of x. So what are we doing? We're putting the f of x on the bottom. So what was inside ends up on the bottom, and there's a 1 on top. And then we're multiplying by the multiplying factor, which is f dashed x. So then we do a tidy up line, and 1 times f dashed x is f dashed x. So over f of x. So what have we done? We've taken the inside of the log and we write it on the bottom of the fraction, and then we write the differential of it on top. So you might learn those words. We put what's inside the log on the bottom, and we put the differential of it on top. So let's see that in practice. And you might want to write down in English and learn it, what I've just said. So we've got y is equal to the log of sine x. So just quick sine cos minus sine minus cos. So I'm now differentiating this. So dy dx is equal to, what's the formula tell us to do? Whatever's inside, stick it on the bottom. What do you put on top? You put on top the differential of whatever's inside. The differential of sine is cos. So the differential of what's inside goes on top. So if we've got y is equal to the natural log of 3x squared plus 7x, when we differentiate this, it's quite simply this. How do we differentiate a log? We write a fraction. What goes on the bottom? What was inside 3x squared plus 7x. What goes on top? The differential of the bottom. Differentiating the bottom, 2 on 3 is 6, so it's 6x. Differential of plus 7x is plus 7. And that's the end of the activity.